Position vector. Let us consider point P in the space with coordinate p, x, y, z with respect to origin 0, 0, 0. So technically what I'm going to do, I'm going to consider a 3D plane. So this is my three-dimensional plane where you can see this is my x-axis, this is my y-axis, and this is my z-axis. So basically this point O is the origin with coordinate 0, 0, 0. The vector along the x-axis is vector I, the vector along the y-axis is vector j, and the vector along z-axis is vector k. What I'm doing, I'm considering a point P with coordinate x, y, z. So if I connect the point P with point O, then this will be my vector R. So how do I write the vector? So in order to write the vector, I can write OP, which is basically vector R right here, is equal to xi plus yj plus zk. So technically I'm writing the x component of vector with I and y component of vector with j and z component of vector with k, and then I'm adding all those terms together to find the vector OP, which is vector R, where I, J, and K are the unit vectors along X, Y, and Z axis. Now, as you can see, I have vector R is equal to Xi plus Yj plus Zk. Now, I need to find the value of the vector, technically magnitude of the vector. So how do I find the magnitude? So the magnitude of the vector is basically the absolute value of OP, which is over here, is equal to absolute value of R, which is over here, is equal to a square root of x square plus y square plus z square. The reason why, because if I use the distance formula, I will basically get the same kind of term, which represents the length between point O and P, which is basically the magnitude of vector OP or vector R. I can also say R is equal to absolute value of vector R, which is equal to square root of x square plus y square plus z square.